surface area and volume of similar solids. So whenever they were just similar, you just did one length to one length. You didn't really have to worry about anything. But whenever it's surface area and volume, you are going to have to make sure that you read what it's saying to be able to get what you need to get. Alright, the figures below are similar. What is the ratio of the volume of the smaller triangle to the volume of the larger triangle? So remember, volume is three-dimensional, right? So whenever we're talking about ratios of volumes, and 4 and 8 are lengths, those are one-dimensional. First, I'm going to reduce it, and then I am going to cube it. 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. So this would be a 1 to 8 ratio of their volumes, which means this pyramid will be able to hold 8 times more than that pyramid. What is the ratio of the surface area? Now remember, area is two-dimensional. And I'm using the 3 and the 6, which is one-dimensional. I'm going to reduce them, and then because it's two-dimensional, I'm going to put the 2 there. 1 times 1 is 1. 2 times 2 is 4. So this is a 1 to 4 ratio, which means if I was to cover it up, I would use 4 times as much wrapping paper to cover this as I would to cover that. Okay, surface area, because the S is surface area. What is the surface area of the cone? So we have 3 to 4 are the lengths. I am going to square those to get 9 to 16. I'm going to put the 81 underneath the 9 because that's where the 9 came from the 3. Let me back it up. Write it a little bit differently. 9 to 16 is the ratio. So I'm going to use the 9 to 16, and then I'm going to put the 81 and the one that we don't know. So we're going to cross multiply and divide. Whenever I do that, 144. The volume below, the figures below are similar. What is the volume of the smaller one? So we're going to do 8 to 4 to get the lengths, which is 2 to 1. But then because it's volume, I'm going to cube both of those and get 8 to 1. Now I'm going to take this 8 to 1 and put this 8 over. It's kind of hard whenever they're the same numbers. That's where those go. And so cross multiply and divide. And the volume of the pyramid is 1. Of the smaller pyramid is 1. Surface areas each are given. What is the ratio of the height of the smaller? If we're just looking for height, height is one-dimensional. Right? These are surface areas. So 225 over 400. And so surface area is two-dimensional, so I'm going to break it down by taking the square roots, because square rooting is the opposite of squaring, and get 15 over 20, which is 3 over 4. And then I want the ratio, so 3 to 4. The ratio of the prism's volumes is 8 to 125. 8 to 125, and that is already the volume. So we are going to cube root both of these, because that's what undoes cubing, is cube rooting. And what times what times what gives you 8? 2. What times what times what will give you 125? 5. So this fraction is one-dimensional. And 2 inches is to what? So 2 to 5, which is this right here, equals 2 to t, which are those right there, and t equals 5 whenever you cross multiply and divide. Below, the ratio of the cube's surface area. So this is surface area, so 16 to 25. So I'm going to break it down into one dimension. So I'm going to square root them as 4 to 5, z to 5, which are those right there. This z and that 5 is this z and this 5. So what is z?